Hello everyone, in this lesson we will solve some problems on similarity of polygons. First, we have multiple choice questions. Choose the correct answer from those given. Question number 1. If K is the scale factor of similarity of polygon M1 to polygon M2 and K is greater than 0 and less than 1, then the polygon M1 is space to polygon M2. M1 may be congruent to M2 or enlargement or minimization of double area of M2. Of course, M1 will be minimization of M2 because K is less than 1 and greater than 0. It is congruent if K equals 1 and it is enlargement if K is greater than 1 and there is no relation. Okay, so M1 is minimization to polygon M2 and we choose letter C. This is the answer. Question number 2. If K is the scale factor of similarity of polygon M1 to polygon M2 and polygon M1 is minimization to polygon M2, then K may be equal 1 or 3 over 5 or 3 over 2 or 0. Here we have M1 is minimization to polygon M2, so the scale factor K must be greater than 0 and less than 1, so we choose letter B. Letter B here. Question number 3. If K1 is the scale factor of similarity of polygon M1 to polygon M2 and K2 is the scale factor of similarity of M2 to polygon M3, then the scale factor of similarity of M1 to polygon M3 is one of these. So the answer will be letter B. So how we get it? If we have three polygons like this, it is just for explanation. It's example. We have three polygons, M1, and I write it here, K1, and the M2 to M3 is K2, and let the length of the side of M1, it is square, okay, is 10 centimeters, and the length of M2 is 20 centimeters. Here is 30 centimeters. 30 centimeters is the length of the third polygon. It is M3. Okay. Okay. K1, it is the scale factor from M1 to M2. Again, K1 is the scale factor of similarity of polygon M1 to M2. So K1 equals the length of the side of the first polygon M1, 10, divide 20. It is the length of the second polygon. Okay, and the K2 equals 20 over 30. Now we want to calculate K3. It is the scale factor of M1 to M3 equals 10 over 30, which equal 1 over 3. Okay, here is equal half. Here is equal 2 over 3 in the simplest form. Okay, how we get 1 over 3 from these two factors. If you multiply k1 multiply k2, it is equal 1 over 2 multiply 2 over 3, and the result equals 2 over 6, which equal 1 over 3. So the scale factor of similarity of polygon M1 to polygon M3 equals 1 over 3. I will get it from K1 and K2, multiplying K1 by K2. Here, notice that K3 equals K1 multiply K2. Then K3, it is the scale factor of similarity of polygon M1 to polygon M3 equals K1 multiply K2. Next question, question number 4. Here we have the two similar polygons that are congruent if the scale factor K satisfies K equals half, K equals 1, K is greater than 1, K is greater than 0 and less than 1. We have two congruent polygons here, so K must be equals 1. So the answer will be letter B. K is the K factor. Question number 5. Here, if triangle ABC is similar to triangle DEF and the BC equals 3EF, then the scale factor of similarity of the two triangles, one of these, we must calculate it. Okay, we have two triangles ABC and the other is DEF, such that BC equals 3EF. Here we have BC is greater than EF, right? So I'll draw two triangles in this form, two similar triangles. Here is the first one and here is the second one. Okay, we have the first triangle is ABC and the other is DEF. Note that BC equals 3EF. Okay, BC equals 3EF. Okay, so if EC equals 10 centimeters, here BC will be 30 centimeters, but we will consider BC, the line segment BC equals 3EF. The length of the side BC equals 3 times the length of EF. So BC over EF equals 3 over 1. 3, it is the coefficient of EF, divide 1 is the coefficient of BC. So BC over EF equals 3 divide 1, which equal 3. So the scale factor of similarity of the two polygons, note that the order of similarity. Here we have ABC, it is similar to DEF. So the scale factor equals 3. BC over EF equals 3. But if we want to find the scale factor, if they write DEF is similar to ABC, okay, we choose 1 over 3. It will be 1 over 3, not 3 over 1. Okay, you must consider the order and notice it. Here we have triangle ABC is similar to triangle DEF. So the scale factor, it will be from triangle ABC to triangle DEF. Question number 6. The scale factor between the square ABCD and the square x, y, z, l equals each of the following except. Okay. First, I'll draw the two squares here. We have the first one, and the other. We have here A, B, C. D, and the other is X, Y, Z, L. So AC, let us write it here, the square ABCD is similar to square X, Y, Z, L. So we can say that AB over XY as a result of similarity equals BC over YZ equals CD over ZL equals AD over XL. Okay. Now the first one here is AC over XZ. Okay, it is equal K, the scale factor of similarity. It is K, right? Here is K. Here it is equal K. It is true or not? Where is AC? We have AC. It is the length of the diagonal, and I'll draw it. Over XZ, it is the other one. The question is AC over XZ equals K. Let us try it. Let us try it in numbers. Okay. To understand the question, consider the length of the side of the square BC equals 3 centimeters, and the length of the side of triangle of square YZ equals 4 centimeters. Okay, what is the length of AC? We have AC equals square root. Here we have 3. Also here the 3 centimeters. The length of AD equals 3 centimeters. So AC equals CD power 2 plus AD power 2, which equal square root of CD square. It is 9 plus 9, which equal root 18. Root 18 equals 3 root 2. Okay. With respect to the other square XYZL, XZ also equals square root of 4 square plus 4 square, which equal 4 root 2. And AC over XZ equals, what is the length of AC? It is 3 root 2 over AZ, it is 4 root 2, which equal 3 over 4. Of course, 3 over 4 equals K, because the similarity factor here is, as we said before, AB over XY equals BC over YZ. The corresponding sides are proportional. Why? Because the two squares are similar. Here, from the given, the scale factor of similarity between the square ABCD and the square XZYL, here BC over YZ also, which equal 3 over 4, equals 3 over 4. So AC over XZ, it is a right statement. Okay. Now what about AB over YZ? What is the length of AB? It is 3 centimeters. What is the length of YZ? It is also 4 centimeters. So AB over YZ equals 3 over 4. So it is right statement here, right? Of course, this is not the answer. Here it is not the answer, because the required here is to find the exception here. Now, what about AB square? AB square, where is AB square? AB square, it is 9 over XY square. AB square, it is 9. Again, AB square over XY square. AB square, it is 9 over XY square, it is 16. Of course, it is not equal to 3 over 4. Okay, not equal K. So this is the right answer here, because the required here is to find the exception here. Here we have BC over YZ. Where is BC? BC equals 3 and YZ equals 4. So BC over YZ also equals 3 over 4. It is equal K and it is not the exception. So we choose letter C. Here is the answer, letter C. Because AB square to XY square not equal to the scale factor, not equal to 3 over 4. Next question. Question number 7. If the rhombus ABCD similar to the rhombus XYZL. Okay, so I'll draw two rhombus. Okay, we have two similar rhombus, because they said here if the rhombus ABCD is similar to XYZL and the measure of angle A equals 60 degrees. So we have ABCD is similar to X in the same order XYZL. The two rhombus are similar, so if measure of angle A equals 60 degrees, so measure of angle X also equals 60 degrees. The scale factor here equals half, and it is related to the length of the sides. Okay, so AB over XY equals half, but the angles, the corresponding angles are still equal in measure. Okay, so we have angle C equals 60. It is from the properties of the rhombus. Here the opposite angle is also equals 60 degrees. Here X equals 60, so the opposite angle also equal 60 degrees. So measure of angle Z equals 60 degrees, and we choose letter C. Question number 8. To make two polygons M1 and M2 similar, it is sufficient to have one of these conditions. A, their corresponding angles are equal in measure only. Of course not. B, their corresponding sides are in proportional only. No. C, A and B together. D, nothing of the previous. The answer is C. So to make two polygons M1 and M2 similar, it is sufficient to have these two conditions, A and B. The first, their corresponding angles are equal in measures. B, their corresponding sides are in proportion. Okay, question number 9. To make two rhombus A, B, C, D and X, Y, Z, L similar, it's sufficient to have A, measure of angle A equals 60 degrees, measure of angle Y equals 120 only. So first we will draw the two rhombus here. Of course, in the rhombus, every two opposite angles are equal in measure, and every two opposite sides, the four sides are equal. Okay, here is the first one. Here we have another rhombus. The first one is A, B, C, D, and the second is X, Y, Z, L. Here is the four sides are equal in length, and here also XY equals YZ equals ZL equals XL. Here we have a measure of angle A equals 60 degrees, and in the first one we can deduce that the rest of the measures of the angle, the measures. Okay, so measure of angle C also equals 60, measure of angle B equals 120 degrees, and also measure of angle D is 120 degrees. In the second one, here, measure of angle Y equals 120, degrees, and we can deduce that measure of angle L also equals 120 degrees. So measure of angle X equals 60. Measure of angle Z equals 60 degrees. And here the four sides are in proportion. So AB over XY equals BC over YZ equals CD over ZL equals DA over LX. Okay, it is from the properties of the rhombus. So it is sufficient that the first condition, it is sufficient that to make measure of angle A equals 60 and the measure of angle Y equals 120 only. So this is the solution. So no need to talk about the sides here. Okay, so to make the two rhombus are similar, it is enough to make measure of angle A equals 60 and the measure of angle Y equals 120. Question number 10. Here, which of the following statements is not true? Each two squares are similar. It's true. Okay, each two equilateral triangles are similar. Also, it is true because the angles are equal. The angles in the equilateral triangle all equal 60. So there is proportional between the sides here, the sides of the first one and the sides of the second. And we have the corresponding angles are equal in measure. Here is 60 and here is 60. Okay, also 60, 60. It is equilateral triangle, right? So H2 equilateral triangles are similar. It's true. H2 rhombus are similar. It is not true here. Okay, we can draw two rhombus here like this one, this rhombus here. I'll give you an example, and you have the length of the first is, let it 5 centimeters, and the other is 10 centimeters. It is an example here. Of course, the four sides are equal in length. So there is a proportional between the two sides of the rhombus. Take the measure of the first angle. Here is 50 and here is 50. So the measure of this, it will be 130, and the opposite angle, it will be 130. Here is another triangle, another rhombus. Consider this as 70. So the opposite one will be 70, and the measure of this angle, it will be 110. Here is 110. So the first condition about the sides are verified. Okay, what that mean? The first side over, here is the first side equal half. We have a similarity factor, or you can say factor of similarity equals half, 5/10. But the corresponding angles are not equal in measure. We know that there is must two conditions to be the two polygons are similar. The first one, that the corresponding angles must be equal in measure. Here this condition is not verified. So when we say that H2 rhombus are similar, it is wrong. Question number 11. The true statement from the following is all the isosceles triangles are similar. It is not true. All the right angled triangles are similar. No. All the squares uses are similar. Yes, this is true statement. All the regular polygons are similar. No. So the required answer here will be letter C, because in the squares all we can take an example for two similar squares. Here we have all the sides are all the corresponding angles are equal in measure. Here we have A, B, C, D. Here we have X, Y, Z, L. So in the square all the angles are right angles. So it is 90. Here is 90, and so on. So the corresponding angles are equal in measure. Corresponding angles are equal in measure. Each equal 90. And the corresponding sides are proportional. So all the squares uses are similar. So the true statement is all the squares uses are similar. Question number 12. Which of the following statements is true? All the regular polygons are similar? No. All the squares are congruent? Of course no. All the equilateral triangles are similar? Yes, it's true. All the rhombus are similar is not true, so the answer is in letter C. Question number 13. If M1 and M2 are similar polygons, okay, and the length of the corresponding sides are 20 and 16 centimeters respectively, then the parameter of polygon 1 to parameter of polygon 2 M2 equals one of this. We know the rule that if we have two similar polygons like this, I'll draw two similar polygons, and we have another one, they are similar and not congruent. Here we have M1 and the other is M2. So the parameter of the first will be the sum of all sides over the parameter of the second. It is a rule. So parameter of M1 over parameter of M2 equals the length of any side of M1 S1 over S2, side 1 over side 2 here, or the ratio between them. It is a rule here. Parameter of the first over parameter of the second equals the ratio between two corresponding sides. Here in the example, we have the length of two corresponding sides equals 20 over 16. 20 over 16 in the simplest form equals 5 over 4, dividing up and down by 4. We have 5, we have divide 4 equals 4. So the solution or the parameter of M1 to the parameter of M2 is 5 to 4, and the answer will be in letter D.